So in this lecture, I'm going to discuss about a simple 8086-8255 interfacing problem. So the question is, because the thing is, in many times we get uh, different type of question based on 8255 8086 interfacing, and we don't understand the inner concept of this type of problem. So here I'll show one example or one problem by which whatever problem they give based on this type of interfacing, you can easily solve. Okay. The question is interface an 8255 with 8086 to work as an input output port. Initialize port A as output port, port B as input port, and port C as output port. Port A address should be 0740 hexadecimal. Write a program to sense switch position SW0 to SW7 connected at port B. The sense pattern is to be displayed on port A, to which 8 LEDs are connected, while port C lower display the number of on switches out of the total 8 switches. So the question is, try to understand the question. So in 8255, 3 ports are there: port A, port B, and port C is divided into 2 parts. Actually, this port C upper and port C lower. Okay, and each of the port is having 8 pins. So in this problem, what they told, one of the information what they have given is port A address is, so port A address is given 070H hexadecimal. And what else they have told? Port A is working as output port. So this is working as output. Okay. And port B is working as an input. Okay. And port C is also working as output port. Is also working as output port. So out of these two part, C upper and C lower, C lower is used while the port C lower displays the number of on switches out of the total 8 switches. So C lower part is used to display how many switches are on, how many display the number of on switches. Yes, display how many switches are on. Now, how to understand how many switches are on? Actually, in this question, it is given port B is a input port where some switches are connected. Okay. Suppose in this port B, eight pins are there. So 8 pins mean 8 switches are connected in port B. And the corresponding display means if you on one switch, then to display that thing means to make you understand that thing, the switch is on, 8 LEDs are connected also correspondingly in port A. Okay. So suppose switch 0, if it is on, then LED number 0 will be glow. If switch number 1 is on, LED number 1 will be glowed or it will be on. Like that, if switch number 2 is off, LED 2 will also be off. Okay, so this is the question given to you. So at a time, suppose 3 of the switches are on. So that corresponding means whatever 3 switches you have made on, that corresponding LED will also be on. Okay, so that you need to find out how many switches are on. For example, if 3 switches are on, so it means 3 LEDs will be on, and you need to give the count value or you need to show the count value in CL. Okay, CL should show that the output is 3, because this example I have told whatever just now I told. Suppose you have 3 switches on, so your CL should show 3. If you make 5 switches on, so it means your CL should show 5. It should display 5, means accordingly it will display how many switches are on or how many LEDs are on. Okay, now this is the problem given to you. Now if this interfacing problem is given, means 8086 with 8255, you need to feed the control word register. A very special function register is there that is known as control word register. Okay, which is there in 8255. Okay. So how you are selecting the port, different port of 8255, like port A, for this given example, port A is working as the output, port B is working as the input, port C is working as the output. So how this you need to decide, that is totally depending on the value of control word register. Okay. Now, very briefly, I will tell, if you want to get this type of configuration, means port A as output, port B as input, and port C as output, what value you need to give in control word register, that I will tell briefly. Okay, so you know in control word register, 8 different fields are there. B7 field or MSB field, it will decide whether you are working in input output mode or BSR mode. So as this question is given in accordance to input output mode, because some LEDs are connected and some switches are connected. So definitely it's a input output problem. So we need to select this B7 as 1. Okay, because it is working in input output mode. Okay, so this actually B7 decide whether you are working in input output mode or BSR mode. So for this given problem, we are working in input output mode. I need to give 1. If you are using in BSR mode, you need to give it 0. So this is not required for our current problem. Now the next two field B6 and B5 will decide the mood of group A. Okay, because I told in 8255 three different ports are there, port A, port B, and port C, whether these are working in input mode or output mode. Based on that, some fields are given and we need to decide accordingly. So mode of A will be decided by these two fields. For the current problem, you know what are the interfacing devices are added here. Here some switches are added and some LEDs are added, and you know very well in case of 8255 interfacing, if LED switches or 7-segment display or relay switches are added, this is nothing but it is indicating that it is working in mode 0. Okay, so mode 0 means you have to decide this value as 00, because this B6 and B5, if you put 00, it indicate mode 0. If you put 01, mode 1. If you put 10, mode 2, and 11, don't care, it's not given. So as some LEDs and switches are connected, it means that if you check the previous video of 8255 interfacing, you can easily understand that if LED or switches are connected, then it means that it is working in mode 0. And mode 0 means your B6 and B5 value has to be 00 only. So these two value has to be 00. Now come to B4 field. So B4 field will decide whether your port A is working in input mode or output mode. So in the question, it is given port A is working in output mode. So if port A is working in output mode, you need to give the value as 0. Okay. If it is output mode, then you need to give 0. If it is input mode, you need to give it 1. Okay. As in the current problem, it is told that port A should work in output mode, so I need to give 0. If it was input mode, I had to give 1. Okay. Now come to the next field, that B3 field. B3 field is nothing but this is the port C upper bit. So this is deciding whether your port C upper is working in input mode or output mode. So in the question, it is given the entire port, whether it is port upper or port C upper or port C lower, it has to be working. It has to be worked in output mode. Output mode means you need to give 0. If it was input mode, you had to give 1. Okay. Now come to the next field, B2 field. B2 field is deciding the mode of port B. As in this problem, I already told this mode 0 problem means simple input means LED and these switches are connected. So definitely it will be working in mode 0 only. Okay, so you need to give 0 here. Okay. Now Next field is B1. B1 is whether your port B is working in input mode or output mode. So if you can remember the question, in the question it was mentioned your port B should work in input mode. So input mode means, as I already told, if something is working in input mode, you need to give 1. If it is working in output mode, you need to give 0. So as it is working in input mode, you need to give 1. Now the last field, that B0 field, it is deciding whether C lower is working in input mode or output mode. In the question as it is given, that entire C is working in output mode. It means that CL is also working in output mode, means you have to give 0. So what does it mean? You this is the actually different values of the control word register. The combination is 1 0 0, then 0 0 1 0. So if you 1 0. So if you find the corresponding hexadecimal value, this is nothing but this becoming 8, this becoming 2. Okay, 4 4 combination, 4 this 8, this is 2. So the value is nothing but 82 hexadecimal. So this value we need to provide in a control word register to work your port A as output mode, port B is input mode, and port C in output mode. Okay, and uh, it is working means 8255 is connected to some LEDs and switches, this type of interface component. Okay, input output component. Now, after that, what you need to do? So in the question, actually, what information you have, port A address is given, but you don't know what is the address of port B, port C, or control word register. Actually, in order to solve this problem, you need to have these 4 addresses: port A address, port B address, port C address, and control word register address. These 4 address you need. The content of control word we got. The content of control word is 82 hexadecimal according to this problem. However, we don't know what is the address of control word register. So address and data are two different things. Okay. In order to make use of 8255 in this configuration, means port A as output, port B as input, and port C as output, what value you need to give in control word register? That is your 82 hexadecimal. Just now we have found out, but we don't know what is the address of 82, what is the address of control word register, that we need to calculate. Now how to calculate? So if I tell you a very simple process, you need to add to whatever address for port A is given, you need to add to value, then you can subsequently get the remaining addresses. So for port B, what do you need to do? 0742, then port C 0746, then CWR 07. Sorry, this should be 44. Yeah, I am adding 2, then it should be 46. Okay. So if you add two values to the previous value, then you can easily get the different addresses. So for port A, if it is given 0740, port B it will be 0742, port C it is 0744, control word register it will be 0740. So every time there is an increment of 2. Now why it is happening? Actually, the address line, if you see how the interfacing is done, that I will tell in the end also after completing this problem. The address line of 8086, this 2-bit, actually A1 and A2 has to be connected to this address of A0 and address line of A0 and A1 of 8255. Okay, this A0 A1 represent this 8255, and this side A0, or for your understanding, you can make it A01 A02, then it will be easy for you to understand. This is for 8086. So what I am trying to say, 8086, this A01 and A02, these two address lines are connected to the corresponding address line of 8255. So which are the lines? A01 of 8086 will be connected to A0 of 8255, and A02 of 8086 will be connected to A1 of 8254. So because of that, if you make some change in this address here, the changes will be to incrementation. How? Because you know A02, if you put in this order, A02, A01, and A00, and we have to select the 4 different components by putting A1 and A0 equal to 0 0, This port A address 01, port B 10, port C 11, CW. So if you put this value, then definitely this value should be 00, 01, 10, 11. So what does it mean? I am not talking about A00 at all. So you can by default you can give it a 0. Okay. Now what is the change occurring? If it is 0, the next value is 2, then the next value is 4, then the next value is 6. Okay. So it means that the port address, whatever you are having, port A address, whatever you are having, port B should be 2 value incremented in port A address if you want to get port B. So if you want to get port C address, then you need to add 2 with the port B address. Likewise, if you want to get control word register address, whatever address of ports you are having, you need to add 2 to that to get the control word register address. Okay, and this is because of this reason, because A02 is connected to A1 of your 8255 and A01 of 8086 is connected to A0 of 8255. Okay, because of this reason. So if you make 4 combination to select each of the port address, so the increment in the subsequent addresses is nothing but 2 to incrementation is there. Okay, so that's why this rule is followed. Now, how to do the programming? What we need to do? So I'm writing the program. What you have to do? To write the program, whatever the necessary things are required that I already told. Now I can write the program. Okay. So first of all, what you have to do is you can write, you can use this register. Okay. I'm writing from here. Move DX. So I'm taking DX register of 8086. DX as 0746H. Why I'm taking 0746H? Because first of all, I need to give proper value in the control word register. That only your particular thing, whatever you given in the question, like port A should work in different in output, port B in input, and port C in output. In these conditions will be satisfied if you give proper value in the control word register. And you know, first of all, you need to find out the address of control word register, which we have calculated, that is 0746. So in 0746, this particular address, I need to give proper value. What is the value I calculated? That is 82 hexadecimal. Okay, so that is only I'm doing first. So I have written move dx comma 0746, and this is, you know, the address of control word register of 8255. Which one? The 0746. That address, in that address, I need to give the value of 82. So first of all, I am sending the address, and that I have given to DX register of 8086. Then what you need to do? Move AL comma 82H. And this 82H, why it is required? Because I need to give proper data in control word register. Then only the conditions will be satisfied. Means port A as output, port B as input, and port C, whether it is upper or lower, both should be working out. This condition will be satisfied if you give 82. So that value I am giving to AL register, and that value means whatever AL is having, that I need to provide to this DX address, because DX having the address of this 0746, which is nothing but the address of control word register. So what I need to do? So because you know you have 8086, from there you need to give some value to the control word register of 8255. So what you need to do, from 8086 you need to give some value to the control word register. So it means that you need to perform out operation. So you need to use out instruction. If you do some movement from 8086 to control word register, you need to use the instruction out. If you take some information, means if you're 8086 taking something from control word register, then you have to use the instruction in. So in this particular case, as I have to give corresponding value, that is 82 in this 0746 address. So what does it mean? That 82 value I am having in my 8086, that I need to give it to control word register of 8255. So I need to perform out operation. So you need to write out dx comma al. Okay. So whatever your al is having means 82 that you are giving to dx. Okay. And dx is having the address of 0746, means you are having the address of control word register. Okay. So initialization or whatever the thing is required to work in this proper way, what is asked in the question, this port A input, port B port A output, port B input, and port C output. This is obtained by using this line. Okay. Now what I need to do, as your port B is working as input, so I need to get the information from port B. So what I need to do, first of all, I need to find out the address of port B. So what I have to do, that is you need to subtract 04 from dx. Now why 04? Because dx is currently having the value. Currently what dx is having, dx is currently having the value of 0746. Now if you subtract 4, and if you update, because sub dx comma 04, what does it mean? 04 you need to subtract from the current value of dx, and whatever value you are getting, that is the updated value of dx. So what value you are getting? 0740, and this is this is nothing but the address of port. 0746 divided by 0746 minus 4. So this is 0742, and this is nothing but the address of port B. Okay. So after that, what I need to do, subtract dx comma 04, means you got the address whatever you want in dx, that is port B address you got. Now from port B you need to, because in 8255 port B your some switches are connected. So whatever values you are applying in the switch, accordingly that value you will be getting, and that has to be transferred to 8086. So switches are working as input. So input means you are giving some data from this side, and that has to come in 8086. Means you are doing an input operation. So you need to use this instruction in. So you write in, as I already told, if you are taking something from 8255 to 8086, then you need to use the instruction in. Okay, so in al comma dx. So dx is giving the address of port B. So in the port B, whatever value you are giving, that you are getting to the AL register of your 8086. This is the meaning of this instruction. Okay. So it means from port B, you have taken the input. From port B, input is taken. Okay. Now, so whatever input I have taken, suppose my switch number 2 is on. So it means that switch number, LED number 2 also has to be glown. So whatever input I have taken, accordingly I need to give proper output. So that I have to give in port B. Port A. Port A is working as the output. So it means that from 8086 to 8255, the movement will be there, or the move will be there from 8086 to port A in that case. So this is nothing but this is a out operation. So I need to use the out instruction. But before that, I need to take the address of port A. So how to get the address of port A? What I need to do? You know very well. So what I need to do? I need to subtract 02 from dx. Why? Because currently dx is having the value of 0742, which is the address of port B, and I want to get the address of port A. So what I need to do? I need to subtract 2. Then I am getting 040740, and that is nothing but the address of port A. I already told in the previous slide. This is the address of port A, this is the address of port B, port C, and control word register. Okay. So now My DX is having the address of port A. Now I can do the out operation because I have to transfer the data from 8086 to control word register to display that thing in port A. Whatever switch was made on, correspondingly that particular LED has to be on in port A. So what does it mean? We have to transfer the data from 8086 to port A. So we need to do out operation. So out operation out DX AL means from 8086 AL register you are giving to DX, and DX is currently having the address of port A. Okay. So this is the simple operations, whatever given in the question we have done. But along with that one, it is also told how many switches you have made on. That you need to count, and that you need to display in port C lower. That part also we need to do. So for that, what we need to do, first of all, I need to take some variable or use some register. Why? To count how many switches are on. So initially I can take move BL register as 00. So finally I will count how many switches are on, and accordingly I will increment the value of BL. Suppose if one switch is on, I will increment BL 1. If the another switch is on, then I will increment it by another 1. So 1 plus 1 it will become 2. So I need to check 8 fields because 8 LEDs or 8 switches are connected. I already told port A is having 8 pins. 8 pins means 8 LEDs are connected. So I need to check 8 of the LEDs or 8 of the switch. Okay, and based on that, I need to take the decision how many switches are on or how many LEDs are on. Okay. So I will I will check each of the field and I will count how many LEDs are on. This is my objective. Okay. And how many field I need to check. So for that, I am taking another register CH, that is I have assigned 08 because I am having 8 pins, or 8 means 8 LEDs or 8 switches will be there. So I need to check 8 positions. So that's why I have taken CH equal to 08. Now what I have to do? After that, what I have to do? You can write a level YY equal to ROL AL. So why you are doing? So whatever accumulator content is there, you can remember that accumulator content only you have transferred to A DX means your port A. Okay, accumulator content means whatever you are having in 8086. We'll be checking that one. Okay, by checking the accumulator content only you can easily find out how many LEDs or switches are. Okay, so what you need to do? You are giving some level YY, then ROL AL. What does it mean? You are rotating the content of AL register. Why? To check how many LEDs are on. Okay. So how to check? Suppose, for example, this was the configuration. Means 3 LEDs were on. So how to check? Every time this content you can do left shifting. Okay. So when you do ROL left shifting, you know whatever the extreme left bit is there, that will come to carry. This is the property of ROL instruction. Okay. So every time if you do left shifting, whatever the bit is there in the left side, that will come to the carry bit. Okay. So by doing that, if you rotate it for 8 times, suppose I am showing the example for 2 times. So first rotation, what will happen? This 0 will come to carry field. This will become 0. This 1 will come to the next left position. This 1 will come to the left position. This 0 will come to the left position, means this is the movement. 1 unit of left shifting, and this 0 will come here. So this 0 is coming. This 0 will be left shifting, or maybe you can think of like that. So this is after first shifting. You know, in this case, carry field is 0. So no need to do any increment of this BL register. If you get some carry, then only you need to increment the content of BL register. Now, if you rotate it next time, what will happen? So now this one will come here in the carry field, as well as this one will also come to the end, that I'll show that. Then this one will come at the front, then this 0, this 0, this 1, this 0, this 0, this 0, and this one will come at the end. This is the configuration you'll get. Now your carry field is having one. Now if you check your carry field, now it means that you have identified this one. Okay, so like that, if you rotate it 8 times, so you can easily identify this one also, this one also. It means the 3 LEDs are on, and every time as your this BL will be incremented after getting one in the carry field, so BL will have the value of 3. That means planning we need to do. So that way we need to write the code. So this is the thing I am trying to do. ROL AL. Then what I need to do? JNCXX. I will write some level. Here you need to jump if carry is not there. If carry is there, means if your carry field is 1, then you need to increment the value of BL. Just now I said. Then only your BL will have this total number of on LEDs. So JNCXX, then increment NCBL. Okay. What does it mean? If there is no carry, then you need to jump to XX level. If there is carry, then what does it mean? This line will also be executed. It will not jump to XX position. It will execute this instruction. What does it mean? BL is incremented by a unit of 1 value. Okay. Because I got a carry means one of the LEDs is on. I found out and I immediately I need to increase the content of BL register. Okay. So as you have done lap rotation one time, what you need to do? You need to decrement the content of CH. Means you have already finished one rotation. You need to do 7 rotation more because 8 elements are there. One rotation is completed and 7 rotation you need to do. So how to do that? Initially my CH value was 8. I have completed one rotation. Then I need to decrement the content of CH. So that's why I have written CH. Then what you need to do? J and Z, Y. Because you need to rotate 8 times. So it means that these things will be executed. This some sort of for loop. This has to be rotated for 8 times because you need to check each of the field. And if some one is there in the carry field, then you need to immediately increment the value of BL. So it can easily give the number of LEDs or switches are on. Okay. For this purpose only this thing is used. So if you come out from this loop, what does it mean? You will be having the total value of BL register that will show the number of LEDs are on. So now you have the value in BL register. What you have to do? Move that value in AL comma BL. Now what you need to do? That you need to show in port C. Now if you can remember, the last value of your DX register was 0740. That is the port A address you had. Now you need to come to the address of port C. Because C lower will show this value, how many LEDs are on. So if you want to come to this port C address, what you need to do? You need to add 4, then only you can come to this port C address. So in the programming also, what you need to do? Add DX04 means you come to the address of port C. Okay. So 04 you need to show in ports means whatever BL value you got, sorry, not 04, whatever value BL value you got means how many LEDs are on, that number you need to show in port C. So it means that you are doing some movement from 8086 to 8255. Okay, we will show this thing 8255 port C will show. And where you are having this number in 8086, you are having this total number, how many LEDs are on. So that information you need to send to your 8255 address, this control word register address. So you are doing an out operation. So you need to write out dx comma al and you need to write fault. So this is the entire program. I hope you have understood this particular problem. Now this problem can be asked in different ways. Suppose if they ask like you have a room where 8 windows are there and you have used 82558086 configuration, means interfacing configuration. And what is the position of the window that you want to detect? So suppose 3 windows are open. So you need to identify by using this configuration that if 3 number of windows are open, then you need to show in port C lower. This way also the question can be asked. It's not like that LED and switches are connected. This type of question will be there. Maybe they can ask like 8 windows are there or 8 smart doors are there where you are using 8255 8086 interfacing configuration to control these 8 doors. So out of 8 doors, how many doors are open that you need to display in port C output? This way also this can be asked. So after that, we can see the interfacing configuration. So this is very simple to understand this configuration, the interfacing diagram actually. So what it is given, this is your 8255 and in this side suppose your 8086 is there. So out of the address line, how many address lines are there? 20 address line. A0 1 to A02 will be connected to A0 and A1 of 8255 and starting address line that is A0 and the remaining thing means A3 to A15 that will be used to select the CS bar. That will be means connected to the CS bar of 8255 chip select bar. Okay, these lines will be used. Okay, so in the while I was discussing about the connection of this address line of 8255 and 8086, I already told the 01 of 8086 will be connected to A0 of 8255 and 02 of 8086 will be connected to A1 of 8255. And these are the data line which will be used between 8086 and 8255. This lower byte of data will be used, and A0 is also used to indicate that lower byte of data is transferred, because you know in 8086 16 data lines are there. So generally for this interfacing operation you will be using this lower byte only, and A0 will be used to indicate that your lower uh, byte is used to transfer the data. Okay. Then after that, your P1 to P7 is connected to 8 LEDs as it is given in the question. This port A is connected to 8 LEDs and port B is connected to 8 switches. And this PC, this lower part. So you know lower part is from C0 to C3 is used to display how many switches are on. And RD has to be connected to the RD bar. RD bar of 8255 has to be connected to the RD bar of. So no need to give this part actually. You can think of like it is working in minimum mode. 8086 is working in minimum mode. So RD bar of 8086 is connected to the RD bar of 8255. And likewise WR bar, right bar also connected to the right bar, and it is connected to this. Okay. So this is all about the configuration. This interfacing configuration. Thank you.